Good evening, colleagues, and warm welcome to Luxoft LTS webinar. Before we start, a few words about our agenda today and our speaker. In a few minutes, Hanno will start his presentation. His speech will last approximately 1 hour, and then we will have questions and answers section. You have an opportunity to interact with our guest through the WebEx client. There's a section in the bottom at the right side of your screen where you can post a question to our speaker. Hanno will comment and answer after his presentation, and in case if many questions appear, you can also contact Hanno directly via LinkedIn and Twitter. Also, if you'd like to know about our latest news and events, please follow our pages on LinkedIn and Facebook. And now let me introduce our speaker, Hanno Embregts. Hanno is a Java developer, Scrum Master, and trainer at the Dutch company called InfoSupport. He has over 8 years of experience already developing enterprise software in various fields, for example, for insurance companies, banks, hospitals, industry, and so on. Currently, he works for the Dutch railway company called NS. He loves building innovative software and has a passion for clean, elegant solutions. One of them he is going to show you right now. So, Hanno, one more time, thank you for joining us tonight, and now it's your turn.
Well, thanks very much, Tatjana. Good evening to you all. I'm very happy to share this story with you, and I hope you want to join me in this journey see what Gradle can do and what can be gained by migrating your build tool. I'll start sharing my screen so you can see what I'm talking about in a few seconds. Okay, here we are. Migrating 25,000 lines of Ant scripting to Gradle. Well, it's quite a lot actually to take in at the beginning, and but don't worry, I'm going to take you through it step by step and tell you what we did at our project at the Dutch railway company. So, welcome again to this LTS webinar. I want to start by telling a bit about myself first. So, who is this guy? Well, my name is Hanno, and as Tatjana already told you, I work for a company called InfoSupport, and the current project I'm working on is for the Dutch train company, which is called NS. Well, NS is the largest train operating company in the Netherlands. We operate about 6,000 trains each and every day, and there are over 7,000 kilometers of railroad track in the Netherlands. And given that the Netherlands is a quite small country, that's just a lot, you know. So it's a very complicated area to work in, but also a challenge, and I love that about it. Some research has shown that the railroad system in the Netherlands is one of the busiest railroad systems in Europe, and therefore it's very challenging to make sure that all the trains will arrive and depart on time, and also that there's a lot of software involved, a lot of software to make sure that these trains are supplied the right information, and that these trains will be at the right destination at the right time. So NS is using a lot of software systems, and one of the software systems that is due to be replaced in the following year is an old mainframe system, which was built in the late 70s, which is responsible for making sure that each train will arrive at the right platform, and also that when a train is very full, for example, very crowded, that there are extra carriages that can be put at the end or at the front. So it's kind of a logistics system. And my project focuses on replacing the system with a modern Java equivalent to be able to keep maintaining it, because, well, there are not very much software engineers that can work on a mainframe system anymore, because it involves very old programming languages. And, well, let's face it, we all like our modern languages, right? So it's much easier to be able to maintain this using Java or any other modern built language. So this project that I'm working on wants to replace this old mainframe system and our case, which we are dealing with this evening, comes from this project. Just to give you an idea what this software system is trying to do. So each and every day we talk a lot about trains and train movements and how to make sure that each platform is supplied with a train and that a train has the right personnel and so on. So in fact, we want to make sure that we know that a train carriage is at the right place at the right time. And if a user of our system discovers that the train is at the wrong platform or it's even at the wrong station, well, then it shows up in our system and we can make sure that it is corrected. So it's a very critical system. It has to be online 24/7. There can be absolutely no downtime at all. So it's very important that also the build script tooling is, up to spec. It's modern. It works relatively fast. So that's why we really needed to do some migration. Well, tonight I won't be talking to you entirely alone. I thought of three very distinguished guests that will help me and sometimes provide some quotes or some remarks on a topic that I think are interesting. And the first one that I want to consult is this guy, Mr. Lin Stovall. He is, as all of you know, I hope, the creator of the operating system Linux, and he also created the version control system called Git. I guess the story behind these names is that Linus always says that he names all the projects after himself. So Linux is called after Linus, and Git, well, he says, I can be very stubborn sometimes, so that's why I called it Git. I like that about him. I like that story. So the second person that I want to consult is Mr. Mark Reynolds. I met him once at the DevOps conference in Antwerp last year. He's a very nice guy, and I learned a lot from him about Java 9, about the modularity system. And he also said some things about Ant and Maven that we are going to investigate, and maybe he will help us through this journey. And the last person I want to consult is this guy, Mr. Louis van Gaal, which is, of course, quite a famous football manager. He's also a Dutchman, so that's why I chose him. Well, he's not managing Manchester United anymore, but while he was managing Manchester United and trying to, failing at winning the Premier League, actually, he said some very funny things, some very blunt things, actually, and I want to use his quotes a little later in the presentation. So, when we get to these parts, you will remember, hey, that's right, Hanno introduced us to these three experts. Okay, so let's first start by giving a bit of background, a short history of build automation. So where did this start, actually? Well, when we started to make software, to build software, and you wanted to be able to run all the code that you created, well, it started actually with a command line call to the compiler. So very simple, actually. It just needed to compile the code that you had created, and it will be translated into runtime code, and you could run it. But of course, software projects got complex very fast. Multi-module projects appeared, and there were a few problems with this single command line call, because there were some order requirements. So there would be module A, which depended on module B. So module B needed to be built first. So you needed to have some tool to make sure that these order requirements were met. So then the tool make was created in the late 70s, which introduced make files, a certain file format in which you could define your builds and could, you could specify some order requirements. So you could say, when you build my project, this is module B and it needs to be built first because there's a dependency from module A. When Java appeared, we all know when it was, 1995, there was a need for a similar build system. So Ant was released in the year 2000, and it actually looks quite a bit like Make, but it's suited for the Java world. So a lot of constructs in Ant were already present in Make at the time, but it's just a Java equivalent. a translation to Java. And a few years later, Maven was released, which took the Java software process, the building process, a step further and tried to help you with the concept of life cycles. So with Ant and Maven, both use XML as a build, as a language for the build files. But in Ant, it's more of a free-form thing, you know. So you can just start anywhere and specify some order. And Maven tries to give you, a head start by saying this is my standard life cycle. So if you just start this life cycle up, you will be, you'll be it will save you some time. So you can just start here, and well, of course you can customize the order, but it's not really necessary at the beginning. Well, I'm not really sure which tools you are familiar with. I've worked with both Ant and Maven and Gradle, of course, so that's my experience, and well, we'll see. Just see what you can, pick up from it. So both of these tools use XML as the language to write the build scripts in. Well, what do we think about XML? I mean, do we like XML or do we hate it? Well, I guess I can speak for all of us when I say that we don't really like it. But let's try to be the good person here, right? Let's start by being nice. So we can say at the beginning, XML really excels at something. It excels at expressing hierarchical data. So data that is organized in some tree, you can express hierarchies very efficiently. So it has some use as a markup language, as a as a language to store some data in. But, and this is a very big but, when you look at build scripting logic, it doesn't really fit a hierarchy. Well, it's not a natural fit because often build scripting logic consists of conditional logic and of repeating logic. Most phases in a build, well, they are just repeated over and over again, and there are a lot of conditionals, a lot of folders that need to be created based on a condition. So it's not really hierarchical at all. It really resembles the concepts of a real programming language. And I think this is why specifying build logic in Ant is so very verbose, because you're using a hierarchical language to express conditional logic, repeating logic, programming language constructs. And this is why Ant scripts are so verbose. So when I heard about Gradle, and there are more build tools that try to do this, it says up front, we're trying to be more like a programming language and less like a markup language. So we want to focus on supporting these conditionals and supporting these iterations that you are using. And the result is that your build script can be expressed much more concisely. And this means less code less code to worry about. So, well, less work to summarize it. Well, our first expert, Mr. Lin Stovall, also thinks a lot about XML. I don't know if you've read some of his stuff before, but he's very critical about data languages. I guess it's because he has done quite a lot with them when he wrote his project system, when he worked on Git. But he really has a strong opinion about XML. When you go to his Google Plus profile, you can read what he thinks about it. And it's the following. XML is crap, really. There are no excuses. XML is nasty to parse for humans, and it's a disaster to parse, even for computers. There's just no reason for that horrible crap to exist. Well, he's a funny guy, this guy. I mean, you should really look at his Google Plus profile if you can spare a few minutes, because this guy just likes to post all kinds of hilarious rants on all kinds of IT automation systems, processes, data languages. There's just a rant for every day. It's great. If you have a few minutes, you should really read some of his stuff. He's great, and now that he's got this out of his system, let's continue, because what is the reason that we are not all using make anymore when we are trying to create a build script? Well, I think it's because the requirements for our build tools have changed. When we look at the past, so let's say the 70s, the 80s, there were really just two requirements for our build software, which was, to begin, it is compiling, because you need to compile this source code to bytecode that can be run. And you need the packages so that you can distribute your software. Well, those were really the two only things that you needed to do with your build tool. Well, nowadays, our software systems have been getting much more complex. For example, in a single project, there could be multiple programming languages that we are using. And it doesn't even have to be a very complicated project for this to hold true, because imagine you are working on a fairly standard web application, then by definition, you need to support multiple programming languages. So let's say you use Java for the backend. Well, then you need some front-end language, which will be HTML5, JavaScript, AngularJS, whatever you want to use. And of course, there will also be a database involved, and you would need some database create scripts, a migration script. So something like SQL, or if you use a relational database. So that's three programming languages already. So it gets complex quite fast. And all these languages need to be supported if you want to run some automated testing. You need to run your JUnit tests automatically. You need to run your user interface tests, and also some data access tests, database migration tests. Well, and all these things need to be supported by your build tool. So it really needs to have a lot more features than it did before. Well, compiling remains. We still have to compile. We can get around that. On this one, I already told you, running automated tests is very important to ensure the quality of our software. Well, packaging also remains. We still need to distribute our software. And also, when we change a few lines of code, it's very important that we integrate this as early as possible to spot some bugs. Well, of course, we don't create bugs, do we? But somehow we still encounter them. So we want to make sure that these bugs are eliminated as early as possible. So you want to integrate it very, very early. And also, this is also something that the build tool should support. And you want it to run quite fast, because this integration needs to happen as early as possible. And of course, when you are ready, so when you think your code is okay and there are no bugs, it needs to be deployed to various environments, test environments, acceptance environments, well, production environments, even maybe not daily, but once a week or once in 2 weeks. It's I think that's the bare minimum. So this needs to be supported also by your build tooling. Well, then we can think about what choices do we have, and what are for the Java ecosystem, and what are the choices that we can consider when we're choosing our build tool. So let's put them, head to head. Let's just let's look at Ant, Maven, and Gradle, and try to pinpoint their strengths and their weaknesses, and when you should, in what case you should use which one. Well, before I want to talk a bit about that, I want to show you what our second expert has to say on the matter. So he was at a DevOps conference, and he was asked a question on Ant and Maven and you know the difference between them. And this is what they asked Mr. Mark Reynolds. They said to him, "What's the difference between Ant and Maven?" And he replied saying this: "The creator of Ant has apologized." And I've checked this, and it's really true. When the creator of Ant, when he created Ant, he thought it was a great system, and I think he was right, because at the time it was needed. You know, we just needed an equivalent of Make for Java. But I guess about 6, 7, 8 years later, he discovered that, you know, the build scripts that you create with Ant were not very elegant, and it was quite a hard job to maintain them, and nobody ever understood what these Ant targets were doing. So he really came clean. He said, "It seemed like a good idea at the time, and sorry, it wasn't. And well, I apologize. I wanted it to be better, and I didn't manage it." So that's, you know, I like this quote of Mark. I thought it was funny. I'm not saying that the creator of Maven should apologize, you know, because well, you know, let's see how Maven will respond to the Ant and the Gradle characteristics, because, you know, Maven could be a very good solution for your project. It wasn't for our project, but I'll get into that a bit later. So let's first see how these build tools perform against each other. Well, let's start with the build script format. We already stated that Ant and Maven both use XML. Gradle tries to be different because they say we want to support all these programming logic constructs as good as we can. So let's use a programming language to define our build scripts. And when Gradle came out, it started supporting use of Groovy in their build scripts. But as of Gradle 3.0, they also allowed Kotlin, which is the language that is developed at JetBrains and also runs on the JVM. So, you know, you can just pick your own preference. What's important to know that the DSL that comes with Gradle is available to both. And it's the DSL is quite important because it provides you with all kinds of references to your project. So runtime in your build script, you could just ask your project, how many directories do I contain, and all those things. So it's very good to keep that in mind. Well, what can we do with these build tools when it comes to dependencies? Well, in Maven and Gradle, there is a built-in dependency manager. When you use Ant, you need to plug in the Ivy library, which also can download the dependencies. I guess the syntax is not very different, but of course with Ant it's more verbose. You know, you couldn't guess it, right? More verbose with Ant again. At my project we have used Ivy a lot, and well, I like the Gradle one a bit better, but I think it's kind of it's a matter of personal preference, I guess. So multi-module builds, which is very relevant to our project because we got a lot of modules. And when I started in the project at the train company about 2 years ago, I took a few hours to assess the end coder that was responsible for creating our multi-module build. And I'm not kidding, it was like 3,000 lines of code. It was just insane, you know. It was my first week on the project, and I thought, well, where's the exit? You know, can I just run away? This is just too much. 3,000 lines of code for just a multi-module build. So, well, I can assure you, when you use Maven or Gradle, it's very simple to set up a multi-module build because there are features of Maven and Gradle. So please use one of these two. I would like to advise you. But you know, we'll get into that later. What should you use when you start a new project? I'll get to that. Well, what's very important for a simple and a logical build script is a predefined structure. and I've told you a bit about this already regarding Maven. It provides you with a life cycle. So there is a predefined structure. If you start up your project, it will execute each and every phase of the life cycle in a certain order. And Gradle works kind of the same way, not with life cycles, but there's a structure that you can just start off. With Ant, there's no structure at all, so you just need to define some targets and go with that, and define some other ones. So you really need to think about, what do I need to do in this project, and what will be my first step, what will be my second step. So it's quite a lot of work to really implement such a structure. And also it's not really mandated, so it's not required to put any structure in your build script at all. And I guess this is the reason why Ant scripts are always so long and hard to understand, because there's no structure required. So who says there will be structure, right? It's more like anarchy and chaos than structure most of the time when I see an Ant script. So I guess that explains it. Well, custom structures. Is it possible with these 3 build tools? Well, yeah, it's possible. I've put non-applicable here at the end column, because Ant is, it solely consists of custom structure. There's no predefined structure. So everything you do in here will be a custom structure. With Gradle, this is very simple. You could just say this particular step needs to be replaced by another one, or you want to extend it, and then you can just do the custom structure. And when you use Maven, it's possible, but it's a bit complex. I've done this a few times, and I thought, well, this is not really working for me, because you need to define. You need to have some plugins. You need to make sure that these plugins are called in the right way. You need to provide some parameters, and it's quite hard to do that. It's still possible, but I found it a bit complex. You also need a lot of lines, a lot of lines of code to make sure that it's better. Well, verbosity. I think I talked about this a few times. With Ant, verbosity is very high, because you need a very large amount of code to make sure that something works. With Gradle, it's quite low, and it's because it assumes all kinds of defaults. So it wants to run with the most default settings, and only the ones that you specify will be overridden. So with a fairly empty build script, you can still run a good Java build. And with Maven, I'd say it's about average, because every time you want to override the standard behavior, the default behavior, you need to provide some custom configuration, which is always in XML, so it adds up quite quickly. But I guess it's about in between and Gradle. Well, how fast will you learn? How fast will you, familiarize yourself with a new build script? Well, this learning curve for Ant is quite shallow. You can know everything about Ant, but when you encounter a new build script or a new, all the build scripts together, it's just very hard to see through it in a very short time. Well, of course, this depends on how well it is documented, but believe me, not many Ant targets are documented as well as they should be. So it takes a long time to get to know the build scripts. I guess with Maven, the learning curve is steep. So, you can just familiarize yourself with it very fast, because each Maven project follows the same life cycle. So you can always see where will it start and where will it end. And with Gradle, I'd say it's about average. You need to learn the Groovy syntax or the Kotlin syntax. You need to familiarize yourself with the DSL. But this structure is present just as with Maven, so it's not all over the place like with it. well, build order is something that all build systems need to provide, because otherwise you could just remain using a compiler call from the command line. In Maven, like I said, the order is based on life cycles, which are predefined, which are executed in the order that are that are defined beforehand. In Ant, you define the build order by specifying depends on relationships. So when you create a target, it should depend on another one. You can just specify that, and the other one will be run first. And in Gradle, this works kind of the same way, but they call it directed acyclic graph, which in fact means that it depends on, like with Ant, but it makes sure that there are no cycles in it. So with Ant, when you create a cycle, it will just run until you get out of memory exception. And in Gradle, it will tell you before you start it, we shouldn't run this because there are cycles in it. So the build order is kind of like how Ant does it. Well, this was quite an extensive comparison. So let's move on to some lighter stuff. I did this talk at the JPrime conference in Sofia, Bulgaria, and I asked the people who were there how many people are using Ant right now, how many are using Maven, and how many are using Gradle. Well, of course, I can't really see what you are, what you are using, but I think that there's some average that we can use. And this is what I came up with. The background of this slide is a whiteboard, which was at the DevOps conference in Antwerp last year. So there was this hallway in the venue that the DevOps was held in, and this whiteboard used to be empty. It was an empty whiteboard at the start of the day, but you know how it goes. A clean whiteboard and some developers. Well, there was bound to be something on it at the end of the day, and I was right. At the end of the day, it was very full, and people started all kinds of popularity contests. It's not really readable, but above this this section, there was a question: do you like AngularJS? And there were lots of people who said yes, and there were also a few people who said no. And some funny guys, they just asked below. They asked, do you like clean whiteboards? And there were 6 guys that said yes, I like clean whiteboards, and a lot of guys that said no, I don't like clean whiteboards. So let's just write them full. And this is the popularity question that I wrote. I was very curious to know, because I was already preparing for this talk, and I was curious about the market share of the build tools. And well, these numbers actually are quite the same as the response I got from the JPrime conference, because about half of the people are using Maven, a little more than half, like 55%, and then 30% is using Gradle, and a few brave souls are still using Ant, and most of them not by choice, of course, because when I got into the project at the Dutch Railway Company, it wasn't my choice to use Ant, but sometimes you just stuck with it. And well, it would be nice to see more people moving over to one of the more modern tools, well, that's what we did, and it really benefited us, and I will explain why in a short while. But what I really want to focus on right now is just do a quick introduction of Gradle. So there's bound to be a few people that have worked with Gradle before, because 30%. But I still want to show a few simple constructs to show you how it works, and then I'll finish up by telling you how we did the migration and what choices we had to make. Well, I'll skip to these slides a little bit faster because I really want to show you how it works. And a lot of these things I already told you. So you already know that Gradle is a build system for the JVM. It's been in development since 2009, and the reason has gained some popularity is because it's the default build system when you try to start an Android project. So this is why it has gained some popularity quite quickly in the past few years. You already know these ones. You can define it by using a Groovy-based DSL or a Kotlin. It uses build by convention quite heavily, so there are some default settings that are assumed, and you can override them by specifying them with custom values, and this is very easy to do. If you want to use additional features, it is all offered in the form of plugins. So if you have a Scala project instead of a Java project, you just import the plugin Scala and you can compile the Scala files. And it kind of works the same way if you want to support some integration tooling. So if you want to use Sonar or Jacoco for your coverage metrics, you can just import the Jacoco or the Sonar plugin and it will execute when you run your build. It also tries to perform incremental builds, so build steps that have been performed before will not be performed again if it's not necessary. Of course, if you've done a clean before you start your build, well, it will do everything again, so you can just specify this yourself. It's widely supported by all build systems, build tools like Jenkins or Travis or Bamboo, so you can use it on your build server, and it tends to be quite fast and efficient. Dependency management is quite advanced. You can just compare it to the Maven one, and it tries to avoid any cycles in your build order before. To summarize all of Gradle's features, it tries to be flexible like Ant, but it also wants to stick to the structure that Maven is so well known for. So you could use all the structure and you can also be flexible if you want. And this is quite of an important point if you want to migrate some existing scripting, because we have tried to migrate to Maven before we started this Gradle migration, and this mandatory structure that it imposed on your build script just didn't work very well with us, because there were all kinds of custom targets that didn't really fit this structure, and we couldn't really find a good place for it in the order. So the fact that Gradle allows you to be very flexible really helped us in this case. So if you define your build in Groovy or in Kotlin, it means that you don't need any XML. So we really should tell Linus about this. No XML, so that's great. It offers a build-oriented model, and this is what it will look like. I'm not sure if you've ever seen a Gradle build file. It's not magic either, so no problems here. But this is kind of a standard build script, which is quite short actually, and this will do just a great Java build. Of course, our Gradle file is a bit longer at the moment because all these dependencies need to be defined, but it's a great start. And it's not very complicated. Well, this is a kind of an illustration on build by convention, so you can see if you adhere to the structure that Maven has become known for, with a source folder and a main folder and a test folder for all your test classes and resources, it will automatically build this and put all the build artifacts in the build directory with the class files and some reports about the tests, and it's like this default structure. So this is standard behavior of Gradle. So of course you can all change these locations if you want to, but it's not really necessary. Of course, this is what I said. It's very easy to override them. You can just define repositories. So you can tell Gradle that, well, I don't want to get it from Maven Central anymore. I want to define my own artifactory or my nexus. So fetch the dependencies from there. And you can also customize your task behavior if you want. Also the build order. You can also say this is build logic that specifically runs just for sub-projects and not for the parent project. You can reuse existing tasks and you can define brand new ones. Well, if you want to use a plugin, I already told you something about it. You can find loads of stuff at the plugins website of Gradle. If there's something that you think it doesn't exist, well, look again, but because I think it will exist, and if it doesn't, it's very easy to create your own. So no problems there. This is what I said. You can just build your own if you want to address specific requirements. You can use almost all JVM languages to write your plugin. So no limitations there, I guess. Well, this is from a Gradle website. I took the screenshot, I guess, about a year ago, something. So I guess there will be more icons, more logos up at the moment. But to summarize this, I haven't found a tool that is not supporting Gradle. So I dare you to find one that not supports it, and then if it doesn't, we'll see how we can fix it. But I guess it will support it. I'm going to skip a few slides because I really want to get to showing Gradle to you. So let's get started. Let's define our first build task. I've prepared a sample Gradle file before, and it has a few tasks. This is the first one I want to show you. It's called Hello Gradle, and it just says hello. This one also always needs to be here because each tutorial needs a Hello World example. So this is ours. I've opened the command prompt at the location of this build file, build Gradle. So and you can just start it by typing Gradle build, and then it will build it. Funny thing, it won't build anything at the moment because I need to specify the task that I want to execute. The Gradle build one is great when you are using a plugin, like I'm going to do next, a Java plugin. Then it will start the compilation, but in this case I need to specify the task that I want to execute. And in this case it's called Hello Gradle. And no surprise there, it tells me hello from Gradle. So let's continue. If I want to show a dependency, it's this one. This task is called hello again, and it depends on Hello Gradle. So it will print this one, but not before it has executed Hello Gradle. So I'm expecting to see these two messages after each other. So let's run hello again. Well, there it is. It tells us hello from Gradle, and then it tells us hello again. So this is the way you can specify your own dependencies. And of course, when you are using a plugin, a lot of these tasks are already available. So if you are using the Java plugin and you are running test, well, of course, this depends on compile. You don't have to specify it yourself, but this is the way that it is done in the Java plugin as well. So it's good to have some low-level knowledge. Just to show you a few quick things on what Gradle is capable to do. I defined these tasks, and the first one is called counter4, and this is a groovy construct that is a loop of a fixed size. So it says the content between the curly braces should be executed, in this case 4 times, and then you can print some message, and you can refer to the index of your iteration. So it's kind of a lambda expression that is executed right here. Well, you would just imagine how many lines of code you would need in Ant to make sure that this would work. It's not a fair comparison. This is just much more elegant. Well, no surprise here, it counts to 4. And because it's this dynamic, you can do all kinds of crazy things. You can use this loop construct to actually define dynamic task definition. So these tasks are all static. I just define them, compile time. But this is a task that's created runtime, and actually it's created 3 times, and it's called dynamic task, and then it appends an index. So it will be called dynamic task 0, dynamic task 1, dynamic task 2. If you wanted, you could also provide some content of this task. I'm not going to do it right now because of, the time, but this is just so super dynamic, and you can just support anything with this if you want. So this is why Gradle is such a good choice for a migration, because no matter what freaky things you encounter in your Ant scripting, this is just, it provides all the tools to be able to cope with it. So it's very cool to see that you can actually execute such a dynamic task. For example, dynamic task 1. It doesn't really do anything, so that's why it says up to date. When you execute Gradle tasks, you will always see a bit of an overview on all the tasks that are defined and the ones that you can run. These are all the standard Gradle tasks that come with every build script. And these are the tasks that I defined. And this is where you can see that this dynamic task is actually repeated a few times. So that's great. It's very dynamic. I like it. So let's get to a more real world example. I've opened up my IDE and I'm creating a new Java project, actually a Gradle project that will use a Java plugin. And I just want to show you how this works, how a Java project will build in Gradle. I've chosen a Java Quick Start template so that it will be working hopefully quite fast. Here it is. No, I'm using Eclipse for now. That's what we use at our NS project, but you can just easily use NetBeans or IntelliJ if you want for the Gradle support. It's excellent in all IDEs. So this is our build Gradle file. I've noticed that the template is quite old, so it uses a very ancient version of Java. So let's update that. Quite nice. You directly get your Gradle dependencies, and if you were to change one of these, so you would say, no, I want version 4.11 of JUnit. Well, it refreshes instantly. So that's just great. Well, if we want to build this project, we have to switch to that folder, of course, and we just have to run Gradle build, and it will build everything. And this is the first time that we've done it, so it needs to build everything. But if you would run it again, you would see the incremental build kicking in, and well, there you go. Nothing needs to be redone anyway, because everything is up to date. Nothing has changed. Now, imagine that I want to compute some code coverage. I would apply the plugin Jacoco, and if I save this and run Gradle tasks again, I will see that there is a new task available, which is called the Jacoco test report. So this is a task that came with the plugin that I just imported. So let's try that one. Let's run Gradle Jacoco test report and see what it does. Now this is interesting. It actually doesn't do anything, and this is because Jacoco test report needs some test results to be able to compute code coverage. And well, it doesn't have any because I didn't run tests. If I really wanted to do this, I would need to run it like this, and then now it has done something. Well, you don't want to remember this all the time, and you don't have to, because you can just define a dependency. So I could just say Jacoco test report depends on test. This is everything that we need, and we could now just run Gradle Jacoco test report, and it will also consider the test phase. Everything is up to date now, obviously, so it doesn't need to do anything. And if you have run the Jacoco task, well, then you can also make sure that these coverage data, you can view them and publish them to your Jenkins or your Bamboo or whatever you want. So there's a this is not the right folder. There's a reports folder, Jacoco test, HTML, index, and there you go. These are these are our coverage. This is our coverage report. You know, I haven't told you this, but the Java template from the Gradle Java templates provides you a standard person class, which doesn't contain anything at all of you tests. So that's why we have some coverage here. Okay, let's see. I've defined the build task. I've extended one. I've defined an advanced task. These were the dynamic tasks. I have also imported some plugins, and I have defined a slot in build order. These things I already showed you. I've already showed you a Java project with its dependencies. I've run some unit tests. I've computed code coverage. And the next one is quite interesting. You can also run an existing Ant target, which is actually very useful if you want to migrate an Ant system, you know. So the next example, and I want to show this by showing you a Java project with all 3 build tools in it. I went a little bit crazy. I thought, why not? I can just create a Java project and activate all 3 build tools in there. So this build project has a build Gradle, which is very short, of course. And it also has a Palm XML to support Maven, which is a bit longer, but it still works. And it also has a build XML to make sure that it can be run with Ant. Yeah, this one actually took me the most time to create. Well, you won't be surprised, I guess. It's quite interesting because this line allows you to run Ant tasks. So you can just say ant.import build XML, just a path to a certain build file. And if you, well, I have to switch folders again, sorry. And if you would run Gradle tasks in this one, you would see that besides all the Gradle tasks, you can also, these are actually Ant tasks. You know, ant.clean, ant.dist, ant.report. They're not actually present in the build Gradle. They are in the build XML, you know, well, they're like this one. So if there are some parts of your Ant build infrastructure that you know before, you won't translate to Gradle because it's too much work or it's not used very often, you can just run them with Gradle. And this is what we did in a few instances, and you know, I liked it. So this is the line that you need to use to make sure that this works. And I couldn't help myself. I also did some profiling. It's not really professional. I just executed a few commands 10 times and took some average numbers. The gray bars are Gradle, the orange are Maven, and the blue one is Ant. It also says right here. And these top 3 results are the response times of the execution times of a clean, and then followed by some other things. So I did a clean and then compile and test. And this cost Maven about 8 seconds. I did a coverage report and I did a publish, which is, you know, a bit more work, so it took longer. And the bottom 3 results are actually the same use cases, but without the clean. And this is where Gradle excels. You can see it right here. Gradle is a gray one. When you do a clean, it needs to do everything over again. And you can see it's a bit faster than Maven, and it's quite a bit slower than Ant. For all these things, actually. But when you don't perform a clean, Gradle is the fastest of them all because of this incremental build feature that it supports. So that's just great. It gets very fast this way. Well, I want to conclude our story by telling you a bit about our migration and how we did this. So let's change to the yellow and blue of NS. You know, our trains are also like this, so that's why the slide needs to change. Let's start by saying that this wasn't a greenfield project at all. Why is that? Well, for starters, it contains 1 million lines of code. Java and SQL scripts, all kind of things. 1 million lines of code in total. And over 25,000 lines of these lines of code were Ant scripting. So that's just insane. It's just large. And as we speak, there are 30 software developers active in this project, still working full time to make sure that it gets finished. And on our build server, on our Jenkins server, this system behaved like a monolith, a classic monolith. So when someone changed one line of code, the entire system will be compiled and tested again. So it was took ages. It was not an ideal situation. And so this is the strategy that we used. First we thought we have a problem with this monolith thing. So let's divide the project into components and let's clearly define some responsibilities. So we did that. We created a component that was responsible for all the training information. And there was one that only did some database transactions. And there was a component that made sure that the platforms were chosen correctly. So according to functionality. And then we started at a very small isolated part and tried to translate it to Gradle. We made it into a verb now. We call this gradling. So start gradling at that very small part with no dependencies. And this is very important because if it doesn't have any dependencies, you can just, translate all you want, migrate all you want, and no one will really, there won't be any harm done. No one will see that your artifacts are different or something, or that it's built with Gradle. No one cares because there are no dependencies. This is a no-brainer, I guess, but migrate on a separate branch because regular development you don't want them to suffer. This is an important one. Verify after each migration step. So after each component, verify the following. Your results should be exactly the same as before, and I mean on a bit level. We had some artifacts that were produced by Gradle, and there had been some changes in the values of the manifest header. So the manifest.mf files, they were a bit different than the encode, and promptly all kinds of tests were failing. And this was bizarre, but apparently there were tests that really checked the values in the manifest.mf file. So they needed to be exactly the same. And also, if you run the other encode, still on your build server, the encode that exists, it shouldn't give any problems. So fix all these problems first before you continue. And this is a very important one, especially when you're dealing with such large quantities of encode. You shouldn't strive to replace every single line. Of course you want to, and in the end, at our project, we also will. But you want to focus on the parts that will make you work faster. And will gain you a lot of time. So focus on the parts that are used very often, like on a daily basis. You also need to tell your project manager why you are doing this migration, and he also wants to know what he will get out of it. And if I'm spending all my time on 1,000 lines of encode that are only executed once a month, well, he doesn't really care about that. If it works, just leave it like that and focus on the things that are the parts that are executed every day, or the parts that need to be maintained every day, so that you can win some time there. And this is a good point. You can just leave some end targets that are not used very often and just call them from Gradle, just as we saw in the code example. This is funny, actually. I wrote an article on Foxed. I don't know if you know them. It's a great blog on Java-related topics. And I wrote something on this subject. The link is here below if you want to read something. It's kind of a summary of this presentation. So I wrote something about our migration, and I also included our strategy by starting at a small isolated part. And the people from Gradle actually responded on Twitter. So this is what they thought of it. They said, I don't know if you can read it, I'll zoom in. They said, starting with zero dependency modules, then fanning out is a smart migration strategy. Delighted to see real-world success stories like this. There's my portrait. I really like this, and I guess I retweeted it also. I really like this. They read my story, and they thought our migration strategy was smart. So, I'm really confident telling you about it, because if the Gradle team thinks it's smart, well, then who am I to disagree, right? So it's great to hear from them. Well, of course, there were a few challenges. I can't tell you right now that everything went smoothly because it didn't. So let's talk about these for a moment. The first one was this dependency spaghetti. In our project, with our Ant setup, we created all these little workspace directories. When we tried to compile a component, we created workspace directories for the class files, and we used the class files somewhere else. And it was all over the place, and it happened in each and every component like this. So dependencies were everywhere, not just in the form of artifacts, but also just folders with class files in it. It was just a mess. So the first thing that we did was go through all these class path folders and all these artifacts that were everywhere. Some artifacts were double present or 3 times present, and even with different versions, it was just a mess. So we just made sure that there was only one version of each dependency, and we defined them in the top build Gradle file, like a common build Gradle file that all components could reach, and then we refer to that one. So we really singled them out, and a lot of build instabilities were solved when we did this, because we didn't have to cope with multiple versions anymore. The second challenge was collaboration with existing Ant code. I've told you a bit about this. There were some tests that tried to verify that our manifest files were okay. They contained the right values, and well, that broke down once these manifest files were different because we built them with Gradle. So some headers were missing and we forgot to add them, and so this code just broke down. So we needed to be able to, our built Gradle scripts should be able to collaborate with the existing Ant code. And well, it was a challenge. We spent a few weeks on this, and when it worked again, we continued. The last one is continuous integration and delivery. Well, of course, this is actually also a no-brainer, but when your complete integration and delivery system is working with Ant and you need to switch them to Gradle, it's quite a task, And we started with this one branch that we created, this migration branch, and we built this branch on Jenkins, and it went okay. But as we added more components and we needed some more tools to, for example, when we tried to plug in Sonar, it just was a bit of a pain to configure it. So the way that we called upon Sonar in Ant was very different from the way we did it with Gradle. And of course, we got it working in the end. But when you're using a Gradle plugin, like the Sonar plugin, these plugins are made not by the Gradle team, but by different programmers, third parties, and not all documentation of these plugins were, as good as the Gradle documentation. So we needed to do some trial and error and make sure that it worked. I'm not sure if we could have solved this. I guess the downside of Gradle is that these plugins are, quite new and maintained by people who are not the Gradle team. So you never know how good the documentation is. But well, we got it working in the end. I guess the first two challenges we could have seen coming before and done something about it. So I hope you guys can learn from it when you want to start your own migration. So let's see what was the result of the migration. Well, at first we divided the system in components, so the responsibility of a component has become more clear. A build will only run if a particular component has changed, so we got much shorter build times on the build server. So there was a component that went from 11 minutes to 3.5 minutes. So that was just a major performance improvement. Well, I haven't actually told you this, but Gradle can run unit tests in parallel, and this is also possible with Ant, by the way. But Gradle decides when to run it in parallel, so you can set it to an auto mode, and it will just decide when parallel running is and when you want it, and it will work. So they can run a bit faster. And we also made sure that these dependencies were not doubly defined, so they behave transitively right now. And there was only one of each. Well, in lines of code, this is a summary. We had over 25,000 lines of code before we started, and there was about 15,000 lines of code that was used so little that we didn't migrate them straight away. Of course, we will do this in a later stage. Eventually we'll do it, but right now we've got some other priorities in our project and we need to get the functionality done. But we replaced over 10,000 lines of code, and these were parts that were used on a daily basis and on a weekly basis even. So, and these like 11,000 lines of end code were replaced by 12,032 lines of Gradle code. So that's just a lot less, a lot less code to worry about. So we're very happy with that. You've been waiting for this. The third expert, my fellow Dutchman, Mr. Louis van Gaal. When you would ask, Louis doesn't know anything about Ant-to-Gradle, of course. He knows about football. But what would he say if you asked him, would you want to migrate all Ant code? Well, I'm saying you right now, it can be done, but it will be a lot of work. And this is exactly what Louis always said when a reporter would ask him, so now you've beaten Sunderland, that was a great match, but next week you are playing Chelsea. So how will you do then? It's quite harder. And this guy is hilarious. He thinks that he can speak all languages fluently. So when he was in Germany at Bayern Munich, he thought he could speak German, and well, actually he couldn't. And in England, he thought he could speak English, and well, actually he couldn't. So what did he say? He literally translated a Dutch proverb. He said, in the Netherlands, they say, that is another koek. Well, you cannot, I won't blame you if you don't understand this, but that is another koek is a Dutch proverb for this is very difficult. That's going to be a lot more difficult than the one we did before. And well, you should just watch this video because no one is actually understanding a word of what he's saying. And the look on his face when the reporters tell him, I don't understand what you're saying. This is not a proverb here. It's just priceless. You should just go watch this. It's great. Yeah. So let's do a quick wrap up. On a migration, if you are using Ant and Maven right now, you will see, and or Maven, you will see that you have some hard to maintain code, a lot of verbosity, a lot of XML lines. And especially with Ant, the purpose of a code fragment is not clearly evident. So they often fail to address changing requirements, and they rely heavily on XML. For these things, Gradle is a better alternative. Why? Because it offers structure and flexibility, and it tries to combine the power of Ant and Maven by being flexible like Ant, but structure like Maven. And it integrates with almost anything. So, well, is Gradle the perfect tool? Of course, it's not the perfect tool. There are some drawbacks. One of them I already told you about. The plugin documentation isn't as well as I would like it to be. And there are a few more. Configuration parsing is a very expensive operation in Gradle. You haven't really seen this in the demo because in Gradle 3, they have improved a lot of performance issues. So, but this used to be a problem in Gradle, the Gradle 2 versions. So the first run of build script would be quite slow, take a lot of time before it did anything. And subsequent builds would be faster. And right now with Gradle 3, it didn't really bother me. So this has improved. But of course, developers need to get used to it. It's quite different than Ant or Maven. And but if they are, Java developers, they will get used to it eventually because Groovy is like Java or Kotlin is Java-like and it's still on the JVM. So it will take some time, but you will get used to it. Well, this is an important point. Migrating existing scripting, especially all existing scripting, is a lot of work, and you should really focus on the quick wins like we did. So the question, should my project use Gradle? Well, if you're starting a brand new project or if you've started just now, I would say just do it and do it right now because now you have the choice to choose an awesome build tool that supports all your needs. And when you have a brand new product, it's just easier to do. So do it right now. And if you have an existing project, well, these are the questions that I asked myself also when I wanted to migrate my project. You need to ask yourself, will you really benefit from Gradle's key features? So do you really need better performance? Do you want your scripts to be more maintainable, less verbose? Do you really struggle with this? Or are your colleagues saying, well, this Maven POM XML is great, it performs okay, we can maintain it okay, so don't migrate at all. Well, then it's okay, if you're happy with your setup, please leave it like that, because it will take a lot of time to migrate it. But when you really can benefit from these things, when you are really waiting on a lot of things on the build server, for example, you should really consider migrating. And if I can share some tips with you, if you have any technical debt like us, so we had some duplicate dependencies, please make sure they are removed. If your product is quite monolithic, please first divide it into multiple components, because your migration will be a lot easier. And define a clear structure in your build logic, because it will be easier to migrate it. Okay, well, I guess this is my part of the story. I hope you liked it, and if there are any questions, please feel free to ask them. I will try to answer them. Okay, actually, I've already seen a few questions, so I will try to answer a few of these. So the first question is by I hope I can pronounce all your names right. I mean, they're great sounding names, but they're not English or Dutch. I'm trying to do this. Marcin Piskovsky, he he asked, hi, do you have any experience how good is IDE support for Gradle projects, in particular Eclipse? Does it perform well, or do you end up with running build from command line? That's a good question. In my demo just now, I used a Gradle plugin. I guess it's developed by the Spring team. Where can I see this? I guess it's somewhere around here. Plugins. Oh, that's very empty. Yeah. It's called the Gradle plugin. You can just look it up on the marketplace. There are two plugins that you can use. I'll just search for them right now. One thing I would like to say about this is this is what I showed you earlier. If you would, if you would just change your version of your JUnit, for example, it will very instantly make sure that it is downloaded from the central Maven. So this works like super fast. It works great. The IntelliJ plugin is also very good, and well, for Eclipse, I'm trying to start up the marketplace, and this is a slow piece of software. It's just takes a short while. So there's the Gradle plugin from the Spring people, and there's the official Gradle plugin from the Gradle team itself. I guess it's called BuildShip. My Eclipse is checking for updates, so it will take some time. You can also perform this search by yourself. BuildShip is the one that is from the Gradle people, and I haven't used it very often because a year ago when we started this migration, it wasn't really finished yet. There wasn't a 1.0 version, so it wasn't very good. So I've used the Gradle plugin from the Spring people. So it's this one with the Spring logo. Gradle IDE pack. This is the one I use, but you can also try the BuildShip one. It might have improved a bit in the past year. So give it a try, and let me know if you like it. Okay. So the question from Artem. Maven proclaims if you know Maven, you can build any project. You just run clean install. What with Gradle? Yeah, it's the same with Gradle. You can just run clean build and it does the same. So if you know Gradle, you can build any project. That's just true. Okay. There's a question from Dimitri Gak. He says, I think such migration will benefit if architecture of solutions changes also. I mean, from monolith to service-oriented architecture. Yeah, of course. I mean, if you are changing your architecture, well, then of course a migration. Yeah, you shouldn't really do it at the same time. I mean, if you have plans to change your architecture, well, by all means, change it first, and then after you've done it, try to migrate to Gradle. You know, you really shouldn't do these two migrations at once. In our case, we didn't really plan to make these components, but we realized that we really didn't have any choice. Gradle support for multi-module builds is just so excellent that you really have to use it, because it will gain you so much performance on the build server. So, you know, we just had to change some of our architecture, and I think it has changed for the better. So, yeah, afterwards we're very happy with it. Okay, a few more questions. Let's see. This is the guy who doesn't want to be addressed. He calls it bruto bo bruto. I'm not sure what that means. Speaking of drawbacks, IDE support was lagging behind Gradle's development at one point in IDEA. Not sure where Jet's Gradle. Right now, yeah. Well, it's not really a question, but I've used the IDEA plugin for quite some time, in a few months, and I really love it. I mean, yeah. I'm not sure. I haven't used it with Gradle 3 actually, so I can. Gradle 3 is not out for a very long time. So I've used it with I think 2.14, and I didn't see anything that didn't work, so I liked it. This is an interesting one. Also from Marcin again. Is there an easy way to run Gradle tasks from Ant? You've shown how it works to run Ant from Gradle, and how is it the other way around? Well, this is a very interesting one. I can't speak from experience on this one, because I have never tried to do it. But I have a feeling it will be possible, because you know, with Gradle you can just run anything. You know, there are plugins to perform command line calls. So you could even do it with such a plugin. I haven't searched the plugin website in Gradle if there's a plugin for Ant, and maybe there is. And if that's true, so you know, you could just look it up yourself on the plugin website, plugins.gradle.org, and see if there's an Ant one. If there is, use that one. If it's not there, you can just. I know for a fact that there is a plugin that allows you to run some command line instructions. So there's one for Bash, and there's one for the Windows command prompt, and you would just be able to run an Ant command in the command plugin. You know what I mean? So that will be possible. But maybe there's an Ant plugin. I'm not sure. You could just check it out. And I'm interested to know if there is. So if you have, you know, researched this, and well, let me know. I'm interested. Let's see. Are there any more questions? Let's see if I forgot anything. Eclipse is pretty slow, right? Yeah, you're right. Eclipse is pretty slow. How do you feel about writing extension classes right in the Gradle config? Oh, that's a good question. Actually, while we did this migration, we wrote our own plugin. It contains some generic steps that needed to be executed all the time, regardless of which component we were building. And we didn't use the Gradle config. We have tried to, because this is what you see in many tutorials. Just grab the Gradle config and write some classes. But actually, we defined our own class files. We wrote it in Groovy actually, so we had we just put it in a different folder and put the Groovy class there, and made a specific location for our Gradle plugin Groovy files. And we had an idea that we thought it was a bit cleaner than just crowding the config files with all these extensions. Especially if you are going to use this extension on in multiple scripts. If your Gradle config is the one place that you use it, well, then you can still consider to put it there. I think that's the one exception. And in all other cases, I would just place it in a separate file. Oh, I see, I forgot a question right here. It's by Artem Nakonechny. He says compile task is predefined in Gradle and test depends on that. Because you run test. Yeah. Yeah, that's exactly right, Artem. So I can run it again if you're interested. This was the Gradle Java. So if I'm running test here, you can actually see in the log what is executed. So compile consists of compile Java and compile just Java and process resource classes. Compile is also a shorthand for a few other tasks. And if you run test, it will search up the dependency tree and test obviously depends on test classes and so on until you arrive at compile Java. And this is the first one that is executed. So yeah, you're right. It depends on compile. Okay, now there's only one question I haven't answered, and it's by Adam Rempala. And he says, what about mistakes with use lots of plugins in the same time? I think you're referring to what if you're using multiple plugins and you discover that they interfere with each other. Well, I haven't really encountered this. For example, let's put a small example here. I have seen build files like this. So it could be that you have team members that prefer IntelliJ IDEA, and other members are maybe developing using Eclipse, where you can actually specify both plugins, and depending on what IDE you're using, the first or the second plugin is used. And this is not this is done by the extension in your IDE, so it will look for this line and use this plugin. So for IDE support, there's no interference, and with other things, Java will always be used standalone. You won't use Java and then afterwards Scala, or because it wouldn't make sense. It could be that you are using both Scala and Java in one project, and then I would recommend to just put all the Scala code in one component and just apply the Scala plugin in that component and the Java plugin in all the other components, and then it will work. On plugin interference, well, I haven't seen it as of yet. Also not with Jacoco or the Sonar plugins. You need to tell the Sonar plugin where Sonar can find the Jacoco code metrics, the coverage metrics. But once you did that, you have done that, they will work both great. They will work great both. So, I haven't found any plugins that interfere. But if you, Adam, if you have encountered this, you can always let me know, on my Twitter, if you have some problems with it, and I will try to reproduce and maybe see if I can help. So maybe I can help with you. I help you later with that if you encounter it.
Well, I think it's time to say thank you to Hanno.
Yeah.
Thanks a lot for a great presentation and for your answers to all questions. I hope that everyone enjoyed this conversation tonight, and I hope that the presentation was interesting and useful for you. We will appreciate if you answer a short questionnaire. You can now see it on your screens. And again, one more time, thanks, and stay tuned for our further events. Good night, guys. Thanks.
Thank you, guys. Bye-bye.